We learned those 3 on Friday, and now we're learning the last 3 today. We're going to talk about inverse, contrapositive, and biconditional. Okay, so we talked about our conditional statement. That's our traditional if-then statement. The converse is what flips them. Okay, I'm going to talk about inverse first. Looking at this example right here, if 2 whole numbers are both even, then their sum is even. What do you think the inverse does? Converse flips them. Look at your table that you guys drew. If 2 whole numbers are both even, then their sum is even. The inverse of that is if 2 whole numbers are both not even, then their sum is not even. So the inverse is kind of the negative of both of them. Okay? And then the contrapositive is the converse and the inverse put together. So what does the converse do? Converse flips it. What does inverse do? What? It doesn't switch it back. What did we say the inverse does right here? Puts not in it. Okay, so contrapositive flips it and throws not in there. So the contrapositive here is if the 2 whole numbers are not even, then the sum of the numbers is not even. Okay, so we're working on putting nots in our statements now. Okay, for example, I'm on page 3 of your notes. Example 4. I want you to write the inverse and the contrapositive of that statement on number 4. Write the inverse and the contrapositive. Okay, if you want to check, here's what I put. My red is the inverse, my blue is the contrapositive. So the red from my original, remember the inverse is we're just putting in not. Okay, we're not flipping anything, we're just substituting in not into our sentences. Okay, the contrapositive is you're flipping it and also having the not in there. Okay? I want to go to our table real quick. Conditional statements. Okay, does anyone have any questions over these 2? Okay, this example, biconditional statements is different than all of the others. Okay, why it's different is because it adds these words if and only if. Okay, so biconditional statements are with if and only if. It's no longer an if-then statement anymore. Okay, so it takes our original if-then and turns it into a if and only if. Okay, right here, that is our if-then statement. Does everyone see what I'm looking at? It's not on your notes, it's just right here. So it says, if a seahorse gives birth, then it is male. Okay, that is our original if-then statement. To write an if and only if statement, it gets turned into this right here. A seahorse gives birth if and only if it is male. What do you understand the difference between our original to our biconditional? What does the biconditional not have? It doesn't have a then, right? It doesn't go the traditional if and then. Okay, it just added the words if and only if. Okay, so look at this table. Let's look at this one together. This is your number 5. If 2 lines intersect at right angles, then they are perpendicular. So what's happening is we're taking out the if and the then, and what are we substituting? If and only if. Yep, so that if and only if goes in the middle of the 2. So what you should have when you rewrite it, at right angles, if and only if they are perpendicular. So we took our original if-then statement and turned it into a biconditional statement. Again, you take out the if and the then, and then you throw in if and only if. Number 6. So when you're given the biconditional statement, it's going to ask you, like if you look on number 6, it says, what are 2 conditionals? What did we say conditional statements were? If-then statements. Okay, so now from our biconditional statement, how do you know if it's biconditional? If and only if, right? If and only if. From our biconditional, we want to write 2 if-then statements. Okay, so one they give you right here is if a triangle is equilateral, then it has 3 congruent sides. And then how do you write the other one? You would just have to flip it, right? So you're writing 2, so then you write the converse, which is if a triangle has 3 congruent sides, then it is equilateral. To talk about truth values with biconditionals, okay, they come from these 2 things right here. We have to determine if they're true. So let's look at that first one. If a triangle is equilateral, then it has 3 congruent sides. Is that true or false? It is true. Okay, so the first one's true. The second one, if a triangle has 3 congruent sides, then it is equilateral. Is that true or false? It is true. This is not on your notes, sorry. So if both of them end up to be true, the whole thing is true. If one of them's false, what do you think it is? False. Okay. If you got the first one to be false, would you even have to check the second one? No. Okay, so in order for a biconditional statement to be true, both of its conditionals have to be true. Okay, go try number 6 on your notes. So number 6, it gives you the biconditional statement. You're writing 2 conditional statements and saying whether it's true or false. Show you up here. Here's my 2 conditionals I came up with if you want to check. So from my biconditional statement, 1, I knew it was biconditional because of if and only if. Okay, so when you're writing your 2 conditionals or your 2 if-then statements, you're taking out your if and only if and putting in if and then. Okay, so once I have the first one, once I have this one, how can I figure out what the second one is? What are you doing to it? Flipping it, which is what? That's the converse, right? That's the converse. Okay, once you have these 2, you want to find the truth value. Well, with biconditional statements, we need both of these to be true in order to be true. Okay, so let's go through it. Number 1, if the product of 2 numbers is negative. First, what's product mean? Answer to a multiplication, right? If the product of 2 numbers is negative, then the numbers have opposite signs. What does it mean, opposite signs? Negative and positive. So is that statement true? It is true. Can I assume the whole thing is true? No, you have to check. If for some reason number 1 was false, would we have to check the second one? No. Okay, number 2, if the numbers have opposite signs, so positive or negative, then the product of them is negative. True or false? It is true. Since both of them are true, is my biconditional statement true? Yes. Questions? This table right here. So inverse, this little squiggle here, that means not. Okay, so here we have our traditional PQ or if then. This says not P, then not Q. Okay, so how it's changing our conditional statement is it's adding nots to both the if and the then. So again, remember P to Q, that means if to then, and then the squiggle, that means not. Okay, it also puts it in words down here for you to look at. Okay, here's a little hint that first period came up with today, to remember what goes with what. So from our original if-then statement, or our conditional, okay, I'm going to put if-then here. From our original statement, we know that from our if-then to the inverse, that's when you add not and you don't flip. First period came up with I for if and inverse. Okay, so from the if statement, for the inverse, you just add not. So I go together. And then when you take the converse, you add not to the contrapositive. And they put that together as CC. Okay, look at talk with someone sitting next to you about that error analysis, number 2. Okay, on this error analysis, it wants us to write the inverse, or it wants her to write the inverse. What does inverse mean? What are you doing to the if-then statement? You're adding knots, right? You're just adding knots. You're not switching anything. You're adding knots. So if it is sunny, then I use sunscreen. What should it be? Yes, she forgot to make this negative in here. So Does it make some sense if I say, if it is not sunny, then I not use sunscreen? No, okay? So you have to make them grammatically correct. You cannot just put not in there and say bingo, okay? So I heard a bunch of you say it should be do not use sunscreen, okay? Number 3, which term is used to describe the opposite of a statement? When you hear the term opposite, just like we were talking with numbers, what do you think? Positive and negative, and what'd you say? Inverse, right? Which term is used to describe the opposite of a statement? That's its inverse, okay? Number 4, how do you write the converse of a conditional? What are you doing to the conditional when you're writing the converse? You're flipping them, right? You're switching. Yep. And then how do you write a contrapositive from the conditional? 2 things, I heard it. Flip and add nots. Yep, I like how you did that. Flip and add not. Number 5, explain how the inverse and the contrapositive of a conditional are similar. How are the inverse and contrapositive similar? They both add not, right? Yep, they both add not. How are they different?
One's flip.
Yep, contrapositive flips, but converse or the inverse stays the same. Good. Okay. Just so I can give you time to do some other practice problems, let's talk about these. Okay. Number 1, we kind of already talked about. What did you guys write? For 6. What did you guys write for your biconditional, Mason?
Number 6.
Yep.
When a number has one in itself as factors, if and only if it is a prime number.
That would work. If you also wrote it the other way, it could be a prime number is prime if and only if its factors are 1 in itself. But yours would have worked too. Yep. Good. Number 7. What is always going to be the hypothesis? The if. What's always going to be the conclusion? The then. Good. Number 8. What is the truth value of the conditional statement? Is if a rectangle has an area of 12, then it has side lengths of 3 and 4. Is that always true? Why not?
6 and 2.
Could be 6 and 2. It could be 12 and 1. Yep. Number 9. Converse. What does the converse do to the original? Flips it, right? So your converse would be if it has side lengths of 3 and 4, then the rectangle has an area of 12 meters squared. Okay, so converse is just flipping. What does the inverse do to the original? Adds not. So if a rectangle does not have an area of 12 meters squared, then it does not have side lengths of 3 and 4. Okay. What does contrapositive do? Flips and adds not. Yep, it does both. So it would be if it does not have side lengths of 3 and 4, then it does not have an area of 12 meters squared. Okay. Last one, number 10. What are 2 conditionals? What does it mean by conditional? 2 if-then statements. Someone give me one from that biconditional statement. Yeah.
If we raise the sales tax 8%, the city can build new roads.
Correct. And then what's the other one from that one? Anybody? So he said, if the sales tax is raised 8%, then the city can build new roads. What's the other one? So what's the converse of that? Someone other than Mason.
If the city can build new roads, then the sales tax is raised to 8%.
Correct. She said if the city can build new roads, then the sales tax is raised to 8%. Awesome.